The question to be addressed in this video is, can we achieve weightlessness only in space, or is there any possibility to feel it on Earth? Friends, one way to experience weightlessness is to take advantage of parabolic flight. It is also known as Comet. It is NASA's program that introduces astronauts to the feeling of zero gravity spaceflight. To understand how parabolic flights create the sensation of weightlessness, we will first review the four basic forces that act on an airplane. The first force is drag. This force is caused by air molecules that obstruct the forward motion of the airplane. The second force is thrust, which is a propulsive force applied by the engine. The third force is weight, which is the product of mass and gravitational acceleration. The final force is lift, which results primarily from the interactions between the airplane wings and the air molecules. It depends upon three factors. Number 1, density of air. Number 2, the shape of the wings. Number 3, the orientation of the airplane in the air. The combination of these four forces determine the speed and the direction of the airplane. Let's now return to the concept of parabolic flight. Friends, to create the sensation of weightlessness, the pilot sets thrust equal to drag and eliminates lift. At this point, the only unbalanced force acting on the plane is weight. So the plane and its passengers are in free fall. This is what creates the zero gravity experience. But the problem is that airplanes can only fall so far before they hit the ground. So prior to this mishap, the pilot aims the plane upward and applies a burst of thrust. So the plane experiences 20 to 30 seconds of free fall as it completes the climb and starts to fall back towards Earth. Finally, once the plane returns to the same altitude it started from, the pilot rearranges lift to return the aircraft to a stable altitude and prepare for the next climb. But there is another option. If it is not possible for you to take a flight in the Comet, we may feel weightlessness by using an elevator. It cannot be an ideal case, but you will weigh less than your normal weight, and this is perhaps the easiest and cheapest way. Let's see how it works. Imagine that an elevator travels from floor 1 to floor 10 and back to floor 1 without a noticeable stop at floor 10. As the elevator accelerates towards floor 10, the passengers feel heavier than normal. As the elevator approaches the floor 10 and immediately changes direction to travel back towards floor 1, the passenger feel the weight less than their normal weight. But remember, during these flights, it is the weight that changes and not mass. Mass is the quantity of matter in any object that remains constant. If you enjoy this video and want to hear me again, be sure to hit subscribe button before you go.